Hello dear students, good morning and welcome to Concrete Civil Concepts again. And today in this interview session 16th, we will be discussing our environmental engineering part B. Okay, earlier we have already completed our 5 subjects of civil engineering like your RCC, like your structure analysis, strength of material, building materials and design of steel structure. Okay, and this is our sixth subject for interview preparation. Okay, and you may find the link in the description, and you may please join the Telegram channel link also in the description box. Okay, and for UPPSC interview preparation. Okay, all the study material for interview preparation will be providing in this channel or in the Telegram channel. Okay, so let's start with our point of discussion on environmental engineering here. And we have already discussed in the earlier overview part of environmental engineering, like what are your qualities of raw water. Okay, in qualities of raw water we have discussed the physical water quality parameters and some part of the chemical water quality parameters. Okay, so in physical water quality parameters, let me remind you or let me revise you that your suspended solids and turbidity and your water and your color, your taste and odor and temperature, these are physical water quality parameters. Okay, next we have our chemical water quality parameters. In chemical water quality parameters we are having your dissolved solids and alkalinity, your hardness, then pH, then your nitrogen content, fluoride content, chloride content, metals, gases. Okay, so these are certain chemical water quality parameters, and in these chemical water quality parameters there are certain limits, acceptable limit and cause for rejection value. Okay, so you must understand or you must keep in mind these limits as well. Okay, like in your nitrogen content, how many types of nitrogen in the form of nitrogen is present in the water, wastewater, in raw water, how many types? So it is your alumina. Okay, so in the form of free ammonium, okay, total organic, okay, and your nitrite and your nitrate. So in this way you just remember these things. Okay, what are blue baby disease, what is methemoglobinemia. Okay, so these are important as well in your nitrogen point of view, and what are your fluoride content and what is the acceptable limit for fluoride content, like your up to the growth of permanent teeth, the 1 milligrams per liter your fluoride is required. Okay, and if your limit is exceeds your 5 milligrams per liter, then your bone fluorosis will occur. Okay, and decolorization of teeth also occurs. Okay, so these are certain limits, like fluoride, your nitrogen is your free ammonia, organic ammonia, or your nitrite and nitrate. So what is the acceptable limit for nitrate? It is 45 milligrams per liter. Okay, and what is blue baby disease? Okay, and there are certain terms in nitrites. So nitrite is important, nitrate is very harmful, so its acceptable limit is 0 milligrams per liter. Okay, and your in conjugation with free ammonia and organic ammonia is known as your Gildas ammonia. Okay, so Gildas ammonia is important and Gildas nitrogen. Free ammonia and organic ammonia is known as Gildas nitrate. Okay, so this is important as well in for interview point of view. And we have already seen your some part of the chemical water quality parameter, like your alkalinity and your hardness for permanent hardness or temporary hardness, permanent hardness and your temporary hardness is for bicarbonate, carbonate and bicarbonate of calcium and magnesium of multivalent cations. Okay, similarly your permanent hardness for your nitrite, chloride or something. Okay, so permanent hardness is not removed by simply boiling. So there are certain special techniques which needs to be adopted for removal of the permanent hardness, like your ion exchange method, your zeolite process. Okay, for temporary hardness, the simple boiling or addition of lime is simply added, and we remove our temporary hardness. Okay, so hardness is measured as CaCO3. We know that hardness is measured as CaCO3. So calcium and magnesium, majorly predominant ions are multivalent cations are calcium and magnesium. So how the hardness in the scale of CaCO3 is measured? So equivalent weight of CaCO3 you have to remember it is 50. Okay, so this is important, so you just remember these things for hardness also. And what is alkalinity? Alkalinity is important. Then pH, negative logarithm of base 10 with hydrogen or hydroxyl ion concentration. Okay, then your dissolved solid is a chemical water quality parameters. Okay, so these all things we have discussed in our overview of environmental engineering. Okay, and we were left with your biological water quality parameters. Okay, in biological water quality parameters there is a term like your endogenous respiration. So what do you understand by endogenous respiration? If your microorganism starts utilizing the carbon of their own cell or your neighboring cell, so they are self-destructing their cell. Okay, and the organic matter is exhausted in the system. If the organic matter is exhausted in the system, then your microorganism starts utilizing carbon from their own cell or their neighboring cell. So this process is known as your endogenous respiration. Okay, what are facultative bacteria? You have to keep in mind what are facultative bacteria. Those bacteria which can act in the presence or as well as in absence of the oxygen is known as facultative bacteria. Okay, what are pathogens? Pathogen disease transmitting microorganisms, okay, are known as pathogens. So and there are certain bacteria, nuisance causing bacteria like your iron bacteria or sulfur bacteria. Okay, so iron bacteria causes your pitting or tuberculosis or okay, so these are important as well in biological water quality parameters. In biological water quality parameters, we have to keep in mind how your pathogens are calculated. Okay, so there are certain methods like your membrane filter technique and your MPN, most probable number. So MPN is a multiple tube fermentation test. Okay, so based on the standard table, we find the results. Okay, and there are certain other methods which are obsolete nowadays, like your MPN is obsolete nowadays. Okay, and this is the way we just calculate your this is pathogens. Okay, so in what in sterline membrane there is a in your what you can say, this is your in membrane filter technique. Okay, in filter membrane technique there are certain microorganisms which retain on the sterline membrane. Okay, and so on this basis we will calculate our pathogens. Okay, so these are important in biological water quality parameters. Okay, and after this biological water quality parameters, we will be discussing the important of your raw water is your treatment of water. So the treatment of water is generally your dependent on the quality of raw water and the desired standard of treated water. Okay, so there are certain treatment of water like your screenings. First we provide screenings either in the form of your coarse screen or in the form of fine screen. Okay, so coarse screen, so the screens are provided at the inclination of 3.6 vertical and 1 horizontal. Okay, so for inclination we get our velocity of flow is reduced, so there is a more opportunity for suspended solids to interact with the screen, so to get sedimented out. Okay, so the heavier suspended solids will be removed from your coarse screens. Okay, so in fine screen we are generally preferring coarse screen, because in coarse screen the diameter is generally 25 mm or the spacing at a 20 to 100 mm. Okay, and in fine screens the wire mesh, okay, and your small openings, due to your small openings the voids gets clogged. Okay, so there is a cost increasing in for your choking of the filter or your screens. So that's why we are preferring only your coarse screens. Okay, so in coarse screens then we prefer aeration. So aeration we do generally for removing the gases like your carbon dioxide and your hydrogen sulfide. Okay, so these are important, H2S or CO2. Okay, so or to remove your minerals also, to aeration, and we are providing aeration for the water sample which is devoid of oxygen. Okay, so for that purpose we will be providing aeration. So how we provide aeration? The interview panels generally ask that we provide aeration in the form of your spray nozzle method, cascade aerator method, and your spray tower method and diffused air method. So there are 4 types of mechanisms or methods by which aeration will be carried out. Okay, and next important treatment is sedimentation. So in sedimentation, what is specific gravity? So specific gravity is your unit weight of solids and unit weight of water in a standard fluid. Okay, so this is our specific gravity, and in sedimentation we should understand the concept of terminal velocity or settling velocity. Okay, and during settling velocity there are certain kind of factors which oppose the settling velocity. Okay, like your settling velocity, your turbidity, okay, or your viscosity. Okay, so we have to reduce the viscosity for constant terminal velocity achieved. Okay, so viscosity is a factor, and there are certain other factors which you should keep in mind. Okay, and in sedimentation, after this sedimentation, there are two types of sedimentation tank, like your horizontal sedimentation tank in and there is a continuous type sedimentation tank. Okay, so in horizontal type, fixed and filled draw type sedimentation tank. Okay, and likewise these are certain, and in sedimentation you should know what are the design parameters of sedimentation tank. Okay, like your surface overflow rate. Okay, what is detention time. Okay, what is the depth of sand. Okay, so these are important, and velocity of flow. How would be the velocity of flow? Let me show you some more points on your sedimentation, like your continuous flow time tank, like your horizontal flow type and your vertical flow type. So horizontal flow type, what are the assumptions made during the designing of continuous flow type tank? That your concentration of particles is same at the inlet portion of vertical section, at the inlet of the cross section. And the second assumption is particle is assumed to be removed when it reaches your top of the settling zone or the bottom of the settling, or top of the sludge zone or bottom of the settling zone. Okay, so there are certain assumptions which you have to keep in mind also. Okay, and other than your sedimentation tank, there are certain data for sedimentation, like we know that overflow rate or surface overflow rate. So plan area of tank is generally determined either from the design discharge upon your surface overflow rate. Okay, so this is important as well. Okay, and then we are having an important parameter like detention time. So detention time, it is in the range of 4 to 8 hours for plain sedimentation tank, and your 2 to 4 hours for coagulation aided sedimentation tank. Okay, and depth of tank is determined by your volume of tank divided by the plan area. Okay, and plan area of the tank is determined either from the design discharge upon your overflow rate. Okay, so overflow rate is generally in the range of 12,000 to 18,000 liter per meter square per day for your plain sedimentation tank, and for coagulation aided sedimentation tank, it is generally your 24,000 to 30,000 liters per meter square per day. Okay, or you can say 24 to 30 meter cube per meter square per day. Okay, so likewise there are certain important parameters again, like your velocity of flow. So velocity of flow is important. It is in the range of 0.3 to 0.9 meters per minute. Normally it is taken to be 0.3 meters per minute. Okay, so length of tank is equal to what? Velocity of flow into your detention time. So detention time is important. Okay, then we are having certain other parameters for sedimentation tank, like your width of tank. So width of tank is generally your 10 to 12 meters, and your L to B ratio is generally 4:1. Okay, so your length to width ratio is generally kept to be 4:1. Okay, so these are important as well. And your horizontal flow dimension tanks, horizontal flow sedimentation tanks are designed for your maximum daily demand. Okay, so what is this maximum daily demand? Maximum daily demand means 1.8 times your average daily demand. And what is this average daily demand? Average daily demand means your population into average per capita demand. Okay, so these horizontal type sedimentation tank are designed for maximum daily demand. Okay, so if cleaning of sludge is done manually, then additional volume for accumulation of sludge is also to be provided by adding 0.8 to 1 meter, 1.2 meters of depth over the design depth. Okay, so these are the certain parameters for your horizontal type sedimentation tank, and for vertical type sedimentation tank, there is a plan area should be calculated as your design discharge upon overflow rate. Okay, so you know these things. Then after this sedimentation tank, we are having another important treatment, that is your coagulation aided sedimentation tank. Okay, so what is coagulation aided sedimentation tank? Means the efficiency of sedimentation is very less okay, when your water contains very fine suspended solids. Hence, to improve the efficiency, the coagulation aided sedimentation tank is adopted. Okay, so the entire process of this coagulation is completed in 3 stages, like your coagulation, that is your fast mixing. In coagulation we is will fast mixing, then your flocculation is a slow mixing, and your sedimentation. Okay, so in coagulation it is the process in which certain chemicals like your coagulants, like your alum, copper as, chlorinated copper as, or your sodium aluminate. Okay, so there are certain chemicals which are added in the water so as to neutralize the negative protective charge over the particles in order to increase the contact opportunity in subsequent stage, is known as your coagulation. So this is important, what is coagulation. Okay, so certain minimum amount of energy is required. So this is energy is known as threshold energy, is provided in the coagulation process by inducing a rapid mixing in the water. Okay, so this is important in coagulation aided sedimentation tank, that what are the other coagulants like your alum, chlorinated copper as, and your free copper as. Okay, so there are certain copper as coagulants which you have to remember, keep in mind. Okay, and what is coagulation, this is important as well. Okay, so after that there are certain flocculation process. So what is your flocculation? And flocculation, in flocculation your neutralized suspended particles are provided with sufficient contact opportunity to agglomerate and to combine and grow in size and to get the finally removed in the falling sedimentation process. Okay, so there are certain rate of flocculation depends upon the following factors, like your turbidity. Okay, so turbidity means your more turbidity, more is the flocculation, will be the flocculation, and the type and dosage of the coagulant. Okay, so types and dosage of the coagulant is very important, and your temporal mean velocity gradient, which is depends upon the power of the shaft. Okay, so there are certain 3 rate factors on the rate of flocculation. Okay, so these are important as well for coagulation aided sedimentation tank. Okay, and then we are having then filtration. So after coagulation aided sedimentation tank, we are having your filtration. So what is the filtration? Filtration means your filtration is most oftenly used to remove the flocks and the finer unsedimented particles. Okay, so flocculation in filtration, in filtration there are 2 types of filters, like your gravity filters and your pressure filters. So gravity filters are further your slow sand filter and rapid sand filters. Okay, and pressure filters are the type of filters in which your water required by the head required by the water to pass through the filter medium is provided artificially by external application of pressure over the water. Okay, so these are pressure filters, and in pressure filters, you know, there are 2 types of in gravity filters there are 2 types of filters, like your slow sand filter and your rapid sand filter. So there are the interview generally ask about your theory of filtration. So what is the theory of filtration? That your biological changes or electrolytic changes or mechanical changes, so and sedimentation. So theory of filtration means biological changes, your electrolytic changes, your mechanical straining, and your filtration. Okay, sedimentation. Okay, these are important as well, and there are certain important provisions you have to keep in mind while you're designing your sedimentation tank. Okay, or your slow sand filter. Okay, so there are parameters and there are certain points which needs to be focused for you guys for interview point of view, like what is a slow sand filter. And in the slow sand filter there is a gravel layer which only support to provide the sand layer. Okay, so the only provision for providing the gravel layer is to support the sand layer. Okay, the next important is your slow sand filter utilizes the effluent from plain sedimentation and only, and large flocks may clog the voids. Okay, because large flocks जो होते हैं आपके वो voids को चौक कर देते हैं. ठीक है, then depth of the tank पता होना चाहिए आपको, 2.5 to 3.5 meters होती है overall depth, और प्लान एरिया जो होता है हर यूनिट का वो आपका 100 से 2000 मीटर स्क्वायर होता है फॉर ईच यूनिट्स. ओके, देन उसके बाद जो आपका मीडियम ऑफ फिल्टर यूज्ड सैंड हो सकता है, एंथ्रासाइड हो सकता है, एंथ्रासाइड मतलब प्लास्टिक मीडियम, और जियोटेक्सटाइल यू कैन से. ओके, देन डेप्थ ऑफ द सैंड लेयर जो आपकी होती है, सैंड लेयर की डेप्थ 90 to 110 सेंटीमीटर होती है, डेप्थ ऑफ द सैंड. ठीक है, और जो आपका डेप्थ ऑफ द वाटर होगा ओवर द सैंड लेयर इज सेम एज द डेप्थ ऑफ द सैंड. ओके, जो आपका डेप्थ ऑफ वाटर की डेप्थ होगी वो भी आपका जितनी डेप्थ ऑफ सैंड होती है उसी के बराबर होती है. ओके, सो दिस इज इंपॉर्टेंट एज वेल। एंड योर ग्रेवल मीडियम की जो डेप्थ होती है वो 60 to 90 सेंटीमीटर होती है। इफेक्टिव साइज पता होना चाहिए आपका सैंड का, जो D10 बोलते हैं 0.2 to 0.3 mm होता है। एंड कोफिशिएंट ऑफ यूनिफॉर्मिटी जनरली स्लो सैंड फिल्टर में हम 5 कंसिडर करते हैं, D60/D10 का जो रेशियो होता है। देन उसके बाद आपको डिजाइन लाइफ ऑफ फिल्टर पता होना चाहिए, वो हम करते हैं 10 से 15 साल के लिए, 10 to 15 ईयर्स के लिए। ओके, और मैं आपको बता दूं तो जो आपका ड्यूरिंग क्लीनिंग जो फिल्टर आप करते हो टॉप लेयर, आप उसको क्या करते हो, हेड लॉस बिकम्स 0.7 to 0.8 टाइम्स जब तक नहीं हो जाता डेप्थ ऑफ द फिल्टर मीडियम, तब तक आप उसको क्लीनिंग ऑफ फिल्टर नहीं करते हो। ओके, तो उस टाइम तक अगर आपका डेप्थ होता है तब आप उसको क्लीनिंग स्टार्ट करते हो। ओके, देन उसके बाद आपको रेट ऑफ फिल्ट्रेशन पता होना चाहिए स्लो सैंड फिल्टर का, 2400 टू योर 4800 लीटर पर मीटर स्क्वायर पर डे। ओके, एंड योर स्लो सैंड फिल्टर इज जनरली अडॉप्टेड फॉर विलेजेस एंड फॉर स्मॉल टाउन्स, and your efficiency for slow sand filter in removing microorganism is 98 to 99%. Okay, ये पता होना चाहिए आपको। Then slow sand filters are not used for water having your turbidity greater than 50 NTU। 50 NTU से अगर आपकी ज़्यादा turbidity है तो आप उसको यूज़ नहीं करोगे। ओके, नंबर ऑफ फिल्टर्स कितने रिक्वायर्ड होते हैं वो आपका पता होना चाहिए, डिपेंड करता है योर एरिया पे। ओके, डिपेंड्स ऑन द एरिया फिल्टर के एरिया पे। अगर आपका एरिया 20 मीटर स्क्वायर से कम है तो आपके नंबर ऑफ फिल्टर्स 2 रिक्वायर्ड होंगे। 2 कैसे रिक्वायर्ड होंगे, 1 एक आपका ऑपरेशनल होगा प्लस 1 स्टैंड बाय में होगा। सिमिलरली अगर आपका जो एरिया है वो 22 to 49 मीटर स्क्वायर के बीच में आ रहा है तो आपका जो एरिया जो फिल्टर्स रिक्वायर्ड होंगे 3 होंगे, 2 ऑपरेशनल एंड 1 इज स्टैंड बाय। देन 250 to 649 आपके 4 फिल्टर्स रिक्वायर्ड होंगे, 3 + 1, 1 इज स्टैंड बाय, 3 इज ऑपरेशनल। देन 649 टू योर 1200 मीटर स्क्वायर एरिया होता है तो आपका 5 रिक्वायर्ड होते हैं। ओके, सिमिलरली ग्रेटर देन 1200 मीटर स्क्वायर है तो आपका जो फिल्टर्स रिक्वायर्ड होंगे वो आपके 6 रिक्वायर्ड होंगे, 5 आपके जो होंगे फंक्शनल होंगे और 1 ऑपरेशनल होगा। ओके, सो वी हैव कवर्ड और योर ट्रीटमेंट ऑफ वाटर एंड up to your filtration part. Okay, we are left with your rapid sand filter, and rapid sand filter is also important, and we will discuss in our environmental engineering session part C. Okay, in our next video will be taking in next week. Okay, so till now subscribe this concrete civil concepts and press the bell icon and share with your friends. If you like the methodology of teaching, then please do subscribe, like, and please join the Telegram channel. Okay, which is given, the link is given in the description box. Okay, so may God bless you. Thank you so much for watching and sharing. So thank you so much.